Okay, so now we're going to shift gears entirely and start to look at something that's going to be pretty foreign to you all, I assume. Uh, and so last week we started talking about how to solve differential equations using MATLAB. And so I want to show you another way to do this, and it's actually a very powerful tool that's in the MATLAB toolbox. It's called Simulink, and Simulink is a graphical tool that solves equations. And so in my work, I use it constantly. That's the main thing we use because we're trying to simulate time-dependent systems. And so what it allows you to do is it allows you to graphically, so here in the middle is shown a Simulink model. You could do the same thing in an M code script, but it's a Simulink model. And it allows you to set up and quickly, accurately model systems that are time dependent, so differential equations. And so this system up here is this is actually a fairly simple system diagram. You guys probably don't have any idea what you're looking at, but there's different blocks here that represent different mathematical equations, different mathematical functions. And so this is an addition block, so you're adding the two lines that come in here. This is a product block, so you have a division, you have one line divided by another. And these two are integrators. And what integrators do is they numerically integrate whatever line, whatever data is coming into them. And so you start to think of it like a flow chart, and each of these lines represents something. So the way I'm going to try to model all of this for you and show you how to do it is I'm going to label every line if I can to show you what exactly everything is doing. And so this system here, like I said, there's 1, 2, 3, 4, 5, 6, really only 5 blocks that are solving an equation. It's 5 blocks here that represent this differential equation, which is pretty complicated. It's not linear, it's second order. It has like a y times a y double dot term, which makes it hard to solve. There's just a lot of things here that make it a little harder to solve. You might be able to do it with ODE 45, you definitely could. But what this shows you is that with this you can do it instead of ODE 45. And the nice thing about this is it allows you to, as I'll show you like towards the end of showing you Simulink, is you can very easily make subsystems that you can copy and paste, much like you do with function files of MATLAB, something you might want to use over and over again. So for example, there's some companies out there, right, that make Simulink tools. And so they make very complicated models of very complicated systems, like subsystems and things, and then they can sell them. Right, you have this really complicated model that someone wants to use, and you can use it really quickly drop into a larger model or something that you want to. I know I'm talking abstractly, but you can drop into something else as part of a greater system. It's something that would take years to develop. Someone's already done it, so you can pay for that tool or whatever. And so this allows for a lot of modularity. It allows for a lot of flexibility as well. And one of the nice things is it's graphical instead of code. And so everything we've done up to this point has been code, right? MATLAB code. I sit down, I start typing out code. Simulink uses MATLAB code. You can make embedded MATLAB functions. You can do a lot of things that we've already done, but it also is very graphical, which I find for myself and from a lot of students, it seems like they grasp that a little bit better because they can kind of see what's happening. You can follow a line kind of through and see what it's doing. And so my goal today is to introduce you to this in much the same way I did with MATLAB, which is how do you use it as a calculator, right? That's how on EGR 1010 you were probably exposed to MATLAB, how I tried to at the very beginning of all of these videos. And so how do you do that? And so the first thing is basic math in Simulink. And so there are, much like MATLAB, there are built-in Simulink blocks that perform set operations. So some of those are addition, subtraction, division, some trigonometric functions that are like sine, cosine, tangent, and all of the family of functions that come up with that form. And then there's just a catch-all math functions block that could be e to the x, x squared, the magnitude, if you're talking about like a vector or a complex number. There's just a ton of functions just built into this math function. And so I have an orange arrow pointing to each of these, and that's because most blocks require both an input and output, meaning you have certain things coming in, and then the output is whatever you did to those things coming in. So for example, you could have like a constant of 1 plus 2 coming in, and the output would be 3. And those could change with respect to time, right? And that's the whole point of Simulink, is it's all time dependent. So you're starting at time 0 to some end time. And these signals could be changing, but you're always doing this set function to them. So in this case, you'd be adding two things together. What's coming in might change, but the output's always going to be the addition of those two. The division. You might be wanting to divide one line by another, one set of data by another that's changing with respect to time, but the output's always going to be one divided by the other, and so on and so forth. Some blocks don't require both an input and output. Those are the exceptions to this kind of general function, this general setup in MATLAB Simulink. And so those are called sources and sinks. And so when I open Simulink and I show you how you use this thing, those are actually labeled sources and sinks. And so a source a source, I think I said this wrong. A source only has an output. A sink only has an input. So a sink is what things go into, and a source is what things come out of. So like a constant and the clock, which outputs time as a signal, are both sources. Things come out of them, and you can use them in your model. A sink is something that you, like a display or a scope, or you could have like a terminator where you have a line going somewhere, you just want to end it. Typically, you're going to be using sources in your models to actually calculate something in an equation. Typically, a sink you're using for some other reason. So in this case, a scope plots an input signal. So if you had something going into a scope, it would make a plot for you with respect to time. The clock function outputs time as a signal. So you're simulating from time 0 to some time, and maybe you're using that time. You need to use that time for something. So you have a math equation that uses time as a variable. This is how you would get that into your Simulink model, is you'd use this clock block. And then constant is just what seems like it outputs a constant number. So we're going to be using that a lot in the next couple examples as well. And so what I want to do is I've explained to you the high-level concepts of everything. And so first I'm going to explain this piece by piece, then I'm going to go build it for you. And so what I want to do is I want to simulate this following equation, y is equal to sine of t plus 2 plus 1 for 10 seconds in Simulink. And so the way I'm going to build this is actually a little bit backwards. Is you have to set it up such that everything, if you remember, is an input. That's kind of the way it works. So I have these two things get put in as an input to the sine function. And so I'm going to start out with, all right, I know that t plus 2 is going to have to go into sine, into the input of sine eventually. So working backwards, I know I need to create t plus 2. And so for those things, I need their component parts, their constituent parts. And so I'm going to need to build t plus 2 first. And so the way I do that is I grab t and I grab a constant for 2, and I put those into an addition block. And so the output of this is t plus 2. And then I know I need to take the sine of that. So I'm going to input that into sine, making the out. So which means this block means apply the sine function to whatever comes in. So in this case, that is t plus 2. So the output is sine of t plus 2. And then to finish off this equation, I need to add 1 to it. And so it's going to be, I grab an add block and input this line here is sine of t plus 2, and I'm going to add it to 1. And then that's my output. And so I'm going to go through this example, and I know I was just explaining that high level, but I'm going to start labeling things as we go, so hopefully you'll start to understand. And so I was messing with some stuff. And so to get the Simulink, let me go to full screen here. You click this Simulink, Start Simulink button here. And so now here's the Simulink start page, and typically you're going to want to create a blank model here. And so now I have a canvas. So before I start to get it side by side to work with it, I just want to show you. I have a canvas here. And this is what I put my blocks on in order to create whatever solution to equation I'm trying to create. And so let's say I wanted to create something, right? I want to actually put blocks in. How do I do that? There's this right here. There's a Simulink library browser. You click on that, it pops up, and now I have a bunch of different options, right? So I've got all these toolboxes down here that are more complicated. We're not going to touch any of those. We're only going to touch a fraction of all of these functions. But there's a lot of things here. There's continuous, discontinuities, logic bit operations, math operations, so on and so forth. But all I'm going to want for right now is the sources and the math operations for this problem. And so that's where I'm going to pull the blocks from to use in my example. So some other things to note is you have this box up here, and I think I have a slide on this later. This box up here is the end time. So if I go and I say, all right, I want to simulate the following equations for 10 seconds, I know that this must say 10 seconds. This gear here has a lot of settings in it, a lot of configuration settings. I'm going to talk about a few of them eventually, but one of them that's nice is I have a solver selection. So there's a lot of solver details here. It doesn't matter for the time being. But one of the things you can do is I can actually choose ODE 45 as my solver selection. I could go down, and these are the other ones that are available even as MATLAB functions as well, alternates to the ODE 45. But let's just use ODE 45, which is a variable step solver. To change to a fixed step solver, you could do that and then choose one of these. Euler is one of them, if you notice. So the Euler method that I taught you, you could use that as your solver if you wanted in Simulink. Let's use ODE 45. It's reliable, it's nice, it'll work for what we're doing. So I'm going to hit OK. And now let's start messing with this problem. So I've got actually, I don't want this model in front of me because it'll just distract me. So let me grab this, and I'm going to make a text block. So one way you can make a text box, you can double click on the canvas here, and then type something in and click Create Annotation. And then if I hit the space bar, it auto zooms in. It zooms to fit. There's also, I think, a button right here that zooms to fit as well. These are just kind of quirks that you'll pick up as you start using it. And so I'm going to try to model y equals sine of t plus 2 plus 1. And so like I said, you kind of work backwards. And I know that I'm going to need this t plus 2 to go into my sine function. So let's build t plus 2 first. So 2 is going to be a constant because it's a constant. It's 2. So let me grab that. So I go to the sources, constant, and I just click on it, and I drag it out here. Constant. And so now I need to double click it. And now I can change the constant value in here to 2. And when I hit OK, it'll change this number to 2. And now I need to do the same thing, find the clock for the t. Remember, t, or time, the output of time is controlled by the clock function in Simulink. So if I go here to sort, I know it's in sources. It's right next to my constant. Click on it and drag it out. Decimation, don't worry about it. You're not going to worry about that. Okay, and so now I know I need to add them. So I can go in to here and grab an add block in the math operations, add. And so one thing to note about the add block is I double click this one to see what its inputs are. Let's see what the inputs for the add block are. You can change the icon shape, that's just aesthetic. But one thing you can do is you can add a character vector containing plus or minus. So you could turn this into a subtract block if you wanted by, instead of doing plus plus, plus minus means to add any of the lines coming in for the plus side of the add block and subtract any that are coming in for the minus. So this would mean t minus 2, right? So my output here would be t minus 2. And so I can, like I said, I'm going to label everything. So this is 2, this is t. And so, but I want t plus 2. Now my output is t plus 2. I'm just labeling my lines so that I know exactly what everyone stands for. And now I know I'm going to take the sine of that, so let's find the sine function. Remember, it's called the trigonometric function. I know it's in math operations because I just know that. And it should be right here, trigonometric function. And the baseline one is the sine function. So I'm just going to connect these lines, right? And so all I did to connect them was actually just drag the input onto that line. And you can just drag it over and it automatically connects it. Or you could have connected it physically. Let's see what some inputs of that are. So there's some approximation methods. Don't worry about it. Don't worry about output signal type. Really what you're looking at is function. And so here's all the crazy amount of functions you could use in place of sine, this trigonometric function block. I'm going to use sine instead. And now my output of that is going to be sine of the input, which was t plus 2. So there's that. And now I need to add 1. So I can grab this add block. I could go back up here to math operations and do it. Another option, if you want to copy a block you already have, you can right-click it and drag it. So I'm going to drag that out here. If you notice, it's called add one. You could add names to all these functions, to all these blocks if you wanted to. And now I need to add one to that. So I'm gonna do the same thing here. I'm gonna right click this constant block, drag it out, and now I have another constant right here. And I changed, all I did there is I double clicked it, changed my constant value from 2 to 1, and now if you notice, it kept the name, so I'm gonna name it 1. If you notice now, all my names have gotten copied along with the block that I dragged. This is now going to be sine of t plus 2 plus 1. And so that's my answer, and I wanted to plot that from 0 to 10 seconds. And so in order to plot, what you can do is you can grab that scope. And I'm going to show you how to actually output things to the MATLAB workspace so that you can, one other way you could plot this is you could run this, you could output to the MATLAB workspace and use the more complicated plotting things that I've taught you to actually plot a good output of this. And that's what I do, is when I run things, I don't plot in Simulink, I plot in MATLAB. So I have an output that I get from whatever Simulink operations I'm doing, and then I have a plotting function I run at the end, and then I run that, and it kind of pops up everything for you. And so what I'm going to grab is in the sinks, you have a scope. And so now when I run this, it will actually plot with in the scope block sine of t plus 2 plus 1. And so to simulate, I didn't really say what I did. I went up and clicked on this run block, and that just means run the whole model. And if there's no errors, it runs. And now I can double click my scope, and here is what sine of t plus 2 plus 1 looks like. And that looks about right? So it shifted everything up by 1 and there's a phase shift by like some, I think it's like, yeah. So this is what the whole plot looks like. Wonderful. So that's the answer to the first question, and I actually had the solution here already, and this is exactly what I came up with. So let's see and so yeah, I have all this running a simulation stuff. So at home, if you wanted to just pop this open, you can. I gave you some pretty basic step-by-step instructions as you do this. So here was your answer. Great, it's good to know that everything looks good. And so now what I want to do is I want to do the same thing, but for this function now. And so I'm going to copy and paste that as well, because I want to use it in. I want to use that as in Simulink. So now I want to simulate that. Oh, I probably should have figured out how much for only 1 second. And so I gave you a hint, the exponential function's found in the math functions block, but I'm going to go look for it. I want to show you a couple more tricks as we start to expand our kind of toolbox of MATLAB things, of MATLAB Simulink functions. And so let me pull up this. And so to open a new MATLAB model, a Simulink model, you click on this button here. You could click on the drop down and click a new blank model. You could do a couple other things. What I want to note is that unlike MATLAB scripts, which I don't know if I ever explicitly said this, but when you run a MATLAB script, it makes you save it every time. Simulink's not the same way. I can run this all day long, and it won't make me save it. So you have to make sure you save it as you go, before you start and as you go. Because when you go to run it, it's not going to save it for you. And that's important. That's an important distinction, because the MATLAB scripting, as you've done your homework, it's probably made you save whenever you go to try to test and run your script, right? Simulink's not the same way. So you have to make sure you're saving as you go, or else you're going to lose everything. All right, and so I'm going to click on a blank model, and I'm going to paste this. So now I have, this is exactly my equation that I'm going to try to represent in Simulink. E to the t squared plus 2t plus 1 minus 2. And so remember, I'm working backwards, so I know that this t squared plus 2t plus 1 is going to be inside of the exponential function. So let's do that first. So t squared plus 2t plus 1, I know I'm going to need the clock, right? And so let me show you a kind of cool shortcut. Is I know that I could open up here and I could go to sources, grab the clock, and that would work. But what I can do instead is I can click on this canvas and just type in clock. Hit enter. If you noticed, it pulled up the clock. So to repeat, I click on the canvas, I type in clock, And if you notice, a couple other things popped up. It actually does this is like a search function. I just do CL. Here's what it found with CL in it. And so I want the clock. Click on it. And remember, this is going to be T. And I'm going to grab another one because I have T squared and 2T. Let me grab another one first and just show you what I can do there. And I'm going to set it up pretty basic for now. And so the first one is I want to T squared. And I know I need a math functions block. And the reason I know that is because the math functions block has a square in it. I just know that. So let me double click it and you can see what it looks like. You can get a preview of it before you add it in there. So if I go in the math functions block, I'm going to double click it. And look, there's a square function in there. There's also a power function. There's a lot of things in here. But I just want the square. And so if I input t into the square function, the output will be t squared. Because this was t, it goes into a square function, it comes out t squared. Now I need 2t, and so now I'm going to show you a new one. There's two ways I could do 2 times t. I could use a divide, which is also a multiply function, or a product function down here. I could multiply it by a constant of 2. That would work right here. Because that output would be, this output here is t. This is 2t, right? Or the other thing I could do is I want to show you a new block that I haven't shown you yet. I'm just going to slowly add these as we go. And this one is a block that means multiply by a constant. It's called a gain. So I pull this gain block out and I add it. And what this does is whatever the input is, it multiplies it by some constant. So in this case, I'm going to have it be multiplied by a constant of 2. This output is now 2t. And now I can add a constant 1. So I'm going to grab a constant block. And I'm adding 1 here to it. Obviously, this is 1. And so now I need to add blocks. I need to add t squared plus 2t plus 1. So I could go in, if you remember where the add block was, it's in the math operations add, or like I just did with the constant, I could type in add, grab it. I know that and here's another shortcut you can do. When you add a block for the first time, if you notice it does this drop down thing, which basically means that you can add whatever function in here that you know there is. So in this case, if you remember, inside the add block, one of the inputs is a list of signs that you have to actually go in and add directly, which correspond to the signs of the add block. And so I know I need 3, right? I know I need to add 3 pluses because I'm adding together 3 numbers here. So I'm going to do plus, 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 hit enter. And if you notice, it added another plus for me to add. So if I could have double clicked it and I could have added plus, plus, plus in the list of signs under the main tab. Both of them work. And so now I'm just going to kind of resize it so everything kind of lines up a little bit better. And let's run this, this, this. And now I can just kind of highlight all this and reconstruct it so it's a little bit in line. Okay, so now that's this section, right? T squared plus 2t plus 1, and so I'm going to label it as such. T squared plus 2t plus 1. Now I want to do something that cleans up a little bit and show you kind of another power of Simulink. If you notice here, I have a t in both of these lines, and so they're equal to each other, which in Simulink means I only need one of these 2 blocks. If I delete this one and connect it here, both of these are still t. So that's one of the nice things about Simulink is you can reroute things anywhere. If I needed this t squared somewhere else in the model, I could grab it. So the way I grabbed that line and pulled something off of it is I right-clicked it and dragged, and like I could pull over here, and this is still equal to t squared. See? So I can pull that and use it elsewhere in the model. But I don't need to do that right now. I just wanted to show you, hey, I could simplify this a little bit more and just have one clock. Pull everything together a little bit more to rearrange. And so now I need to apply the math function e to the whatever, the exponential function. And so I know that's in my math operations in math function. It's even the default. And so now if I input t squared plus 2t plus 1, my output is now e to the t squared plus 2t plus 1. Right there. Now I've gotten to that point, and now all I need to do to get this equation finished is I need to subtract 2 from it. And so the way I drag this canvas around is if you hold the space bar and click right and left click, you can drag it all around. And so now I need to subtract 2. So I'm going to go to the add block. And remember, subtraction is just addition of a negative number. And so the thing I can do here is I can add I can subtract 2. So I'm going to right click this constant block, drag it over here, connect it, and subtract 2. And so I need to change this plus sign to a minus sign to make it subtraction. All right, so now I'm saying e to the t squared plus 2t plus 1 minus 2. And so I've gotten my final answer. It's this. So now I can go and plot it. And remember, the easiest way to plot it here is for me to grab a scope block. I know what it's called, so I'm going to type it in here. So I'm going to click and type scope, hit enter, connect it, and now I'm set to run. And remember, I'm only running it for 1 second in Simulink. So I'm going to come up here, click on 1 second, hit run, and let's see what I got. That looks the same as my answer, doesn't it? It does. All right, and so that is the solution to that problem. So hopefully me stepping you through a couple examples has helped, because we're going to kind of start moving from here into other topics. So what I want you to do is take some time to do your own problem. And so as normal, I want you to do this in-class problem here. I just showed you the solution. Whoops. So I want you to simulate this equation for 2 seconds in Simulink using a scope block. We'll simulate it for 2 seconds by building this equation, and then I want you to plot it using a scope block. And so I told you where to find these, and this is what your plot should look like in the end. And so this is a little more complicated, right? I have e to the negative 2t times sine squared of t, but I've shown you everything you need to know to use this. So I want you to see if you can put it together. And so take your best crack at it. It doesn't matter if you get the right answer. Just submit something at the end of the week, or on Wednesday as normal. And so I'm going to end it there. And next time we'll pick up with solving differential equations in Simulink.